Okay, I misspoke at the end of the last uh, video. I said we were going to go on to case 3, and there's actually a case 2B, and that's where they shift the 100 centimeter over, uh, and the 200 they send it over the same distance, and they ask you to calculate where the 50 would be. Well, we didn't use the 50 because that was off scale. We used um, the another 100. So I have here. Let me put it. I have the 100 at 20, and I have the 200 at 60, and it's balanced. Why is it balanced? Because lo and behold, I've got another 100 right here at 45.2. And if you calculate where, instead of the 50, calculating the 50, where a 100 would be to balance it out, I got zero point 0.8. I'll let you do the calculation, and you need to show your calculation in the lab report. But if certainly if I take off this, you can see how it caused an imbalance. So let's balance it back up. We have the 200 at 60, 200 at 60, and the 100 at 20. And this, I think I didn't put it quite in the same place. It's like 44. You can see that puts too much torque on this side. So I'm going to move it over. And there it is at 45, about 45.2. So 45.2. I calculated about 0.8. I'm actually getting about, it might be 45.2, 45.3. Let's call it 45.2. What is the center at 46.4? I said. So we're a little bit off, and that's going to be a percentage difference. Why? Well, it may not. It may be that the yardstick isn't exactly uniform. It looks uniform, and probably for the most part it is, but there could be other factors that enter into our area. So that's case 2B. Okay, so case 2B, we have 100 at 20. We have, let me adjust them. That looks good. 100 at 20, 200 at 60, and we have 100 at, well, it looks like 45. I'm going to call it 45.3. Okay, 45.3. So that's your data for case 2B. And now we're going to go ahead and go on with case 3.